Okay, question number 1. Race car driver has completed 12 and a half laps of 50 lap race. Okay, what fractional part of the race remains? So what fractional part of the laps remains? So first of all, we need to know how many laps it still remains, right? So it is going to be 50 minus 12 and a half, because completed 12 and a half laps. So left over 37 and 1/2 laps left to go, right? Now it's asking what fractional part, meaning how many percent practically, or what part of the entire race it's remaining. When we are talking about a part, which part of the race, so to find out, we need to take this 37 that left over, because it want this leftover figure out what part of the entire race make. So we take 37 1/2 divided by 50, or 37 1/2 we divide by 50. That means this is gonna be 75 over 2, right? 37 times 2 and plus 1. I will put at the end of the this recording the link to the video how to convert regular fractions, simple fractions, into a proper and improper fractions. Okay, and divided by 50, meaning to divide by 50 meaning we flip this 50 and multiply by 1 over 50, right? So 75 and 50, we can both of them divide by 25. Here will be left 3, here will be left 2. And the result is going to be 3/4, or 75%, still have to go. 3/4 is a 75%. How did I find out? Divide 3 by 4 and you will get 0.75, which will be 75%. But it doesn't ask how many percent, it asks fractional part. Fractional part, it's going to be 3/4. Okay, question number 2. If M is the set of positive multiples of 2 less than 150, so important part here, positive number, which is positive multiple of 2, which is less than 150, and N is a set of, again, positive numbers, but this time numbers of multiples of 9, and again less than 150, so our limit going to be 150. How many members are there in M and N? So how many members are multiples of 2 and 9 that is less than 150? Let's find out. So what do we have? We have positive multiples. M is a set of positive multiples of 2. N is a set of positive multiples of 9. So because we need to find how many members are there in M and N, meaning how many elements that can be multiples end of 2, end of 9 for M and N. So we need to find the common multiple for 2 and 9. It's going to be multiplication, and common multiple will be 18. All right? Now let's find out. Less than all numbers, less than 150, that can be divisible by 18. So it's going to be 18, then 36, times then 54. What I do, 18 times 1 times 2 times 3 72, 90, 108, 126, 144. That's it. That's a less than 50 condition. So how many we have? 1, 2, 3, 4, 5, 6, 7, 8 elements total, and that is our answer. All right? Next. At Bruno's Video World, the regular price for DVD is D dollars. It's not giving you a specific amount of dollars. It just say D dollars. So price of DVD is D dollars. Okay. How many DVDs can be purchased for X dollars? You have X dollars total. When DVDs are on sale at 20% of regular price. So the regular price is gonna be 20% off, meaning 100 minus 20% of D, right? It's gonna be 80% or 0.8 D times D. Now, 0.8, I'm going to write down 8 over 10 represent in the format of simple fraction. So reduced by 2, both of them, it's going to be 4, this is going to be 5, and the result will be 4/5 D. So this is going to be discounted price of the DVD. This is a price that has 7% off the regular price. Regular price is 100%, 20% off. That means they are selling for 80% of the price, and which is 4/5 D. Now you have, let's say, you have X amount of dollars, and you want to purchase a DVD for 4/5 D price. So how do you know what to do? If you have $5 and you want to know, if you want to know how many breads you have that cost $2, you're going to divide by 5 by 2, right? Same is here. You have X dollars and you want to purchase DVD for the price of 4/5 D. So we take X, and divide by 4/5 of D. Well, I put in the numerator D, because in the middle or in numerator it's the same thing. Here, it's the same thing. So when I divide, practically the second fraction I have to flip and do multiplication. 5 over 4D, yes? And the answer is going to be 5x over 4D. These many DVDs we can buy. 5x over 4D DVDs we can buy. We good? Question number 4. If Dave drove 1/3, mark down, 1/3 of the distance of his trip on the first day, and then 60 miles of the second day, he figured out that he still had 1/2 of the trip to drive. What was the total length? So the question that is asking for total length, that one is going to be our X. Usually unknown, our unknown is the what the question is asking for. Since it's asking for total length, then our unknown is going to be total length. So total length is x. Now, first day, he drove 1/3 of his trip on the first day. So it's going to be 1/3 of x. Second day, he drove 60 miles on the second day, which means he drove first day 1/3 x. So next day another at the 60 miles, so plus 60, correct? And that means he figured out he still had to drive 1/2 of the trip. So he still have to drive, which means 1/3 of x plus 60, it still will be, that's total 1/2 of x. He still have to drive. Since he has to drive 1/2 of x, that means he drove another half of the trip, right? So this is that one. This is not the one that half need to drive. That's the one that he drove half already. Okay? It just happened, the distance is the same. All right. So from here, if we solve it, 1/3 of x minus 1/2 of x is gonna be negative 60. Actually would be better, hold on, would be better if 60 would be, I would leave it on the left side, and on the right side 1/2 of x minus 1/3 of x. So this way I will have positive on both sides. I don't have to go through division by one negative number. Okay, so 60, we have 2 and 3. I'm thinking bring to entire equation to common denominator, or just subtract 1/2. Let's bring to entire denominator, 2 and 3. In the denominator is going to be 6, right? So here 6, we'll divide by 6, multiply by 6. Here we have to multiply by 3 to get 6. That's mean here also multiply by 3, because whatever change we do to denominator or one part of the fraction, we have to do exactly same change to the other part of fraction. And here to get 6, we multiply by 2 here, by 2 here. And once we bring to the same denominator across the equation, you cannot leave any term. Once you leave one term at least, that's it, you won't get the answer. Okay? So now we can drop this because denominator is the same. If denominator is the same and we have equal sign, it's equation, that means numerator has to be the same also, which means 6 times 60, it's going to be 360 is equal. 1 times 3 is 3x, and minus 1 times 2 is 2x. And our x, the whole distance, is equal 360 miles. Next one is question number 5. Oops. So, here's the question. If two x is actually 1x, if x is not equal to y, then how much will be x minus 2y over 2y minus x plus 2y minus x over x minus 2y. Okay. Well, x cannot be equal to y. That's a requirement because if it would be equal, we will get 0, right? And we would get division by 0, correct? Okay. So, what is interesting, denominator looks similar, same, but it's not. Here we have 2y minus 6, here we have x minus 2y. What we're gonna get? To make them equal, look here, 2y minus x. What if I put negative sign in front and in parentheses I'm going to flip the sign? Positive 2y will become negative 2y, negative x will become positive x. Or I can rewrite first x, it's going to be negative x minus 2y. So, and I didn't disbalance any expression, because if you open this negative sign, you're still going to get negative x plus 2y, which is same to y minus x, right? Just like here. So what I want to say, you can put negative sign in front of parentheses, create new negative sign, and switch the terms with positions. You had 2y minus x, 2y minus x, now you have x minus, now you have x minus 2y. That's all. And we need this very often. In many problems, we are going to face something like this. Let's say if you have in a denominator 3 minus x and another denominator x minus 3. All you're going to do, this 3 minus x, put equal, put negative sign in front, and in parentheses x minus 3. And that will be absolutely legit and correct. So, what I'm going to do here, I'm going to put negative sign in front of second fraction and flip the denominator, which is going to be x minus 2y, 2y minus x, I put here negative sign, and I will have 2y minus x, and here 2y minus x. Okay, this is going to be interesting. So 2y minus x, 2y minus x, it's going to be cancelled, right? I will have here 1. So I will now, what I'm going to do here, I have x minus 2y and 2y minus x. I put negative sign in front of this fraction. Here also I will have, well, I'm changing the numerator, doesn't matter. 2y minus x, put negative sign and put 2y minus x, here also 2y minus x. And minus 1, right? Here we have minus 1 left. And here is going to be, this is gone, this is gone. So I have left, that's a nice problem, negative 1, negative 1. And the answer is going to be negative 2. That's all. Okay. Next question, question number 6. If x squared minus y squared equal 48, then 2/3 of x minus y times x plus y is equal. How much is going to be equal? First of all, x squared minus, let's do drafting here, x squared minus y squared is x minus y, x plus y, right? So this piece is equal to this piece. All we need to know, this is the same, right? X squared minus y squared and x minus y, x plus y. So, which means 2/3 of it, it's going to be 2/3 of 48, right? So I'm taking 2/3 multiply by 48. When you're multiplying by whole number, that whole number goes to numerator, because 48 I can represent as a 48 over 1, right? Okay, this is 1, this is 16, and the answer is 32. So which means the 2/3 of x minus y times x plus y is equal 32. For now, I will record it again. So, and I see you in next video.